Welcome to the Periodic Table Foundation, Part 2, with the Boys and Girls Club. Come on in and we'll continue learning about the foundation of the periodic table.
And now, ASAP Science presents the elements of the periodic table.
There's hydrogen and helium, then lithium, beryllium, boron, carbon everywhere, nitrogen all through the air with oxygen so you can breathe, and fluorine for your pretty teeth, neon to light up the signs, sodium for salty times,
magnesium,
aluminium, silicon,
phosphorus,
then sulfur, chlorine, then argon,
potassium,
and calcium so you'll grow strong,
scandium,
titanium, vanadium, and chromium, and manganese. This is the periodic table, noble gases stable, halogens and alkyl react aggressively. Each period will see new outer shells while electrons are added, moving to the right. Iron is the 26th, then cobalt, nickel coins you get, copper, zinc, and gallium, germanium, and arsenic, selenium, and bromine film, while krypton helps light up your room, rubidium, and strontium, then yttrium, zirconium,
niobium,
molybdenum, technetium,
ruthenium,
rhodium, palladium,
silverware,
then cadmium and indium,
tin cans,
antimony, then tellurium, and iodine, and xenon, and then cesium, and barium is 56, and this is where the table splits, where lanthanides have just begun, lanthanum, cerium, and praseodymium. Neodymium's next to promethium, then 62, samarium, europium, gadolinium, and terbium, dysprosium, holmium, erbium, thulium, ytterbium, lutetium, hafnium, tantalum, tungsten, then we're on to rhenium, osmium, and iridium, platinum, gold to make you rich till you grow old, mercury to tell you when it's really cold,
thallium,
and lead, then bismuth for your tummy,
polonium,
astatine would not be yummy,
radon,
francium will last a little time,
radium,
then actinides at 89. This is the periodic table, noble gases stable, halogens and alkali react aggressively. Each period will see new outer shells where electrons are to the right. Actinium, thorium, protactinium, uranium, neptunium, plutonium, americium, curium, berkelium, californium, isonium, fermium, and olevium, nobelium, lawrencium, rutherfordium, wm, sprigium, boreum, hesium, pneumonium, dubsidium, rhenium, copernicium, nihonium, flerovium, moscovium, livermorium, tennessine, and oganesson, and then we're done.
So what do you need today? You need your thinking cap, the periodic table if you have one. If not, we'll supply one throughout the video as you need it. Pencil and paper, and a lap book or a notebook. If you don't have these supplies, that's okay. Come on in and learn anyway. And don't forget to pause the video as you go and restart as you're learning. Okay, come on in and let's get started. Our objectives today are understand what elements need to be organized, how the periodic table was developed, and what information about the elements is provided by the periodic table. Are you ready? Let's jump on in. We're learning about the periodic table. This is the foundation of the periodic table, Part 2. Continue learning with us with all of our other videos that we have, and we'll have another part to this video coming up as well. This is the periodic table. You've seen this many times if you've watched our videos, but we'll talk more about this soon. What information does the periodic table contain? This is actually considered also a periodic chart. It is a chart of the elements arranged according to the repeating patterns of their properties. Elements that have similar properties are grouped together. For example, groups there are 1, 2, 3, 4, 5, and more groups that go down the chart, and periods that go across. The periodic table is arranged in 7 rows called periods. The rows go across and the groups go down. A period runs from left to right, and the properties of the elements change in a pattern. For example, metals are on the left, metalloids are along the zigzag, and non-metals are on the right. The metals are on the left, metalloids are the zigzag in the lime green, and non-metals are on the right. We're going to talk about that a lot more as we move on. How is the periodic table useful to us? An element's properties are so important and can be predicted from its location on the periodic table, where it's located. The periodic table is also arranged in 18 columns called groups or. See the group? The group is everything along that line. All right, it's your turn to practice. Let's do this together. Don't forget to pause the video after each one. So, use the periodic table to name the group and elements you would expect to have the properties of the following: calcium, aluminum, krypton, and oxygen. Don't forget, hint, 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 anything in a group would have the same properties of anything else in that group. Let's start with calcium. So anything that's in the same group must have the same properties. Pause the video and name a few elements that would have the same properties of calcium. Very good. If you said that magnesium, maybe barium, radium, if you said some of those would have the same elements as calcium, you are correct. You ready for the next one? All right, so what about aluminum? Pause the video. If you said boron, indium, thallium had the same elements and properties, same properties as aluminum, you are correct. Okay, let's try krypton. Pause the video. Okay, if you said krypton had the same elements as xenon, argon, neon, helium, radon, you are correct. One last one. Let's do oxygen. Pause the video. If you said oxygen had the same properties as sulfur, you are correct. Very good. All right. Now you have learned that calcium, aluminum, krypton, and oxygen all have similar properties based on their groups. The elements in each group have similar properties. Their groups such as alkali metals, alkaline earth metals, transition metals, and their nitrogen families, and the noble gases. We're going to learn more about each of those groups and the properties within them in the next video.
And now, ASAP Science presents the elements of the periodic table.
There's hydrogen and helium, then lithium, beryllium, boron, carbon everywhere, nitrogen all through the air with oxygen so you can breathe, and fluorine for your pretty teeth, neon to light up the sign, sodium for salty times,
Magnesium,
aluminium, silicon,
phosphorus,
then sulfur, chlorine, and argon,
potassium,
and calcium so you'll grow strong,
scandium,
titanium, vanadium, and chromium, and manganese. This is the periodic table, noble gases stable. table. Halogens and alkali react aggressively. Each period will see new outer shells while electrons are added, moving to the right. Iron is the 26th, then cobalt, nickel coins you get. Copper, zinc, and gallium, germanium, and arsenic. Selenium and bromine film, while krypton helps light up your room. Rubidium and strontium, then yttrium, zirconium,
Niobium,
molybdenum, technetium,
ruthenium,
rhodium, palladium,
silverware,
then cadmium and indium,
tin cans,
antimony, then tellurium, and iodine and xenon, and then cesium and barium is 56, and this is where the table splits, where lanthanides have just begun. Lanthanum, cerium, and praseodymium. Neodymium's next to promethium, then 62. Samarium, europium, gadolinium, and terbium, dysprosium, holmium, erbium, thulium, ytterbium, lutetium. Hafnium, tantalum, tungsten, then we're on to rhenium, osmium, and iridium, platinum, gold to make you rich till you grow old, mercury to tell you when it's really cold, thallium, and lead, the bismuth for your tummy,
polonium,
astatine would not be yummy,
radon,
francium will last a little time,
radium,
then actinize at 89. This is the periodic table. Noble gas is stable. Halogens and alkali react aggressively. Each period will see new outer shells while electrons are to the right. Actinium, thorium, protactinium, uranium, neptunium, plutonium, americium, curium, berkelium, californium, isonium, fermium, and olevium, nobelium, lawrencium, rutherfordium, wm, sprigium, boreum, hesium, pneumonium, dubsinium, mercenium, copernicium, nihonium, flerovium, moscovium, livermorium, tennessine, and organesson, and then